directly opposite from me, and its role is to look at what is the accuracy of the parts that are being produced. So if the student does a drawing and creates a 3D model of it, there's points all over the place that can tell us what are the dimensions. That machine is designed to compare the produced part, let's say these ski goggles, to what has actually been designed. What are the errors? How much does that material stretch or bend or twist when it freezes from liquid plastic to solid plastic? Or something like this boat motor or propeller, is that we want that propeller to be accurate because it's going to affect its balance. So if we put that into the CMM, it's going to look all the way around that part, which is part of normal quality control, and to say, did we design or did that part get produced correctly? So students can create the design models in CAD drawings. They can produce the part in the rapid prototyping, make sure they've got it right, then actually take it across the street where there is CNC machines, and we can actually machine that part out of aluminum or steel or stainless, whatever you want it. So that's just examples of what students have created, and believe it or not, a crescent wrench that actually functions right out of the prototyper. It's a wrench, but it's an adjustable wrench, so that jaw will open as you spin this little gear here. And that's right out of the prototyper with no.
These are basically made by the students with the machine, with the help of this machine.
3D printing. So we not only have this within formal classes, but students can get engaged in our Maker Club, where they can get into designing software. They can create that software, they can create these models, and get advice from peers, faculty, industry as well. So that's a way for them to get engaged with what we do here. So it's not only CMM, we've got strength of material testing that can be done in here. We can stretch things, we can crush things, we can see how they deform. An example might be mild steel versus hot rolled steel versus stainless steel. If we make bolts out of all these, when do they fracture? When do they deform? Is the product that you selected going to meet the standard or the expectations of strength, depending on the design that you create? So students get a better understanding. Would I use mild steel for the bolts that hold the wheel on, or would I use high strength steel? And they can find out when that's going to fail, and is it going to meet expectations. So it's more about pure mechanical principles rather than a specific marketplace application. So a bolt's a bolt's a bolt.
I just wanted to highlight our third-year students. At the end of their training, they have this project. It sort of culminates everything that they've learned. And I just wanted to highlight, this is actually a panel built by a student that's a motor control system that protects and controls the motor. And this student just presented this last week. He did all the wiring, he did all the design work, he did all the testing. This is all student built. And then the unit that's standing right behind there is another unit that's built by students. And that there is just this panel right here. This panel here is to simulate an electrical panel you find in a house, regular home. And the beauty of this panel is it allows you to hook up a bunch of loads to it, but then it also has these plastic pieces of conduit that have single conductors running through it, so you could actually put clamp-on amp meters onto this to measure the current that's flowing through it without exposing the student to any danger of electricity. So it's all protected. But these are student projects that students have built, either through tech report or through research. This was a research project, actually. Yeah.
Where we basically wanted to look at, when you turn everything on in your house, your computer, your stove, your microwave, your fridge, all that kind of stuff, what is the total energy that's being consumed, and what does it look like? We expect a nice, smooth sinusoid, and it's anything but. So if we put that complication into the power system, we've really started to